We are adding an owner-only list of pending workspace invitations. The result looks simple. A current owner sends one GET request and receives 200 OK with a management identifier, canonical recipient address and expiry for each invitation that is still open and usable. The response excludes expired, cancelled, and accepted rows. It excludes every other workspace. It also excludes the raw acceptance code, its stored hash, tenant identifier, issuer, accepted user, lifecycle timestamps, and concurrency version. The response carries a no store cache directive because recipient addresses are private administration data. A member receives forbidden, an anonymous caller receives unauthorized, and a stale owner session receives forbidden. The useful outcome is not merely a list. It is a deliberately narrow view across a mutable tenant boundary. Use for decisions to reason about a secure read. First, authorization decides who may ask. The existing tenant-owner policy checks the authenticated session. Second, trusted tenant context decides which workspace the request means. A query string never chooses scope. Third, lifecycle filters decide which records are pending. Open is not enough because an expired row can remain unclosed until a later command settles it. Fourth, projection decides which columns may cross the HTTP boundary. These decisions belong in that order. A perfect response record does not save a query that loaded another tenant first. A tenant predicate does not save an endpoint that serializes code hashes and internal audit state. Security comes from the whole path, current owner, selected workspace, live pending state, and a small allow list. Design the public shape before writing the database query. Pending tenant invitation has exactly 3 properties. ID is the non-secret management handle introduced for cancellation. Email is the canonical address already stored for recipient matching. Expires at tells the owner when the capability stops being usable. Notice what is absent. Tenant ID comes from the selected session and would add no value to this screen. Code hash is still security-sensitive internal material even though it is not the raw code. Issued by user ID, accepted by user ID, closed at, accepted at, and version belong to audit or concurrency behavior, not this task. An entity framework entity is a persistence model, not an API contract. A dedicated record turns the response into a visible allow list that future properties cannot silently expand. The new route shares the same path as issuance but uses GET. It accepts no body and no tenant identifier. The owner identity, security stamp, and membership version come from authenticated claims, while the selected tenant comes from iTenant context. A supplied tenant ID query value is simply unrelated input and cannot redirect the query. The route reuses the existing tenant-owner policy for the outer check, then passes those trusted coordinates to the store for a live check beside the data read. If the store cannot prove the same current owner tuple, the endpoint returns forbidden. A successful response sets cache control to no store before returning the array. This is a snapshot, so a later cancellation or acceptance remains authoritative even if an earlier screen still displays the row. Authorization claims describe the session when its token was issued. Workspace authority can change afterward. The store therefore opens a serializable read transaction and reuses the same live owner query as issuance and cancellation. The user must still exist with the selected tenant, the membership must still be active with the owner role and expected version, and the identity security stamp must still match. Returning null means authority could not be proven, returning an empty array means authority was proven but no pending invitations exist. That distinction lets the endpoint preserve forbidden for stale sessions without inventing data. Keeping the owner check and invitation read inside one transaction gives the operation a consistent database view. A read endpoint can leak private state, so mutable authorization deserves the same care as a write. The database query starts with the selected tenant ID and closed at equals null. That tenant predicate is the isolation boundary. Another workspace's recipient addresses never enter application memory. As no tracking avoids change tracker overhead for a read-only snapshot. The query projects the safe 3-field record immediately, so code hash and internal lifecycle columns are not selected for the response path. After materialization, one captured clock value removes expired records. Closed at alone is not the definition of pending because an expired invitation can remain open until issuance closes it during replacement. The get does not close expired rows. Read should not quietly become cleanup commands with new concurrency and retry behavior. It reports usable invitations now, lifecycle transitions remain in issuance, acceptance and cancellation. The teaching application uses SQLite, which cannot reliably translate ordering over date-time offset. Episode 2 already taught us to treat provider behavior as real behavior. The safe compromise here is precise: filter tenant and closed state in SQL, project only the allow listed fields, then filter expiry and order that small safe list in memory. Ordering by expiry, canonical email and identifier makes repeated responses deterministic. We do not call to list on the entity set and filter tenant afterward. In a production SQL Server application, the provider can perform the date comparison and ordering in SQL, and a large list should gain an explicit pagination contract. The important boundary remains unchanged: foreign rows and hidden columns never cross into the in-memory result. A tempting shortcut is to load tenant invitations, filter them in C# and return the entities. That creates 3 problems. First, every workspace's recipient data enters memory before the tenant check. A later logging statement, exception dump, or refactor can expose it. Second, entity serialization follows persistence shape. Code hash, tenant identifiers, issuer data, accepted state, and concurrency version can appear when the model grows. Third, developers may notice expired rows and close them during get, turning a safe read into an undocumented write. The secure sequence is explicit: validate current authority, apply tenant and open state filters in the database, project the 3 allowed fields, materialize, remove expired snapshots and order the safe records. Small response records are a security control, not ceremony. Provider-backed integration tests drive the real identity endpoints, tenant context, policy, entity framework store and SQLite provider. The main test seeds 2 current invitations plus expired, cancelled, accepted, and foreign workspace rows. It sends a forged tenant query value and still receives only the selected workspace. Every JSON object must contain exactly ID, email, and expires at. The body must not contain the issued code, its hash, tenant ID, issuer, accepted fields, closed time or version. Cache control must be no store, and deterministic order is asserted. Database assertions prove the expired row remains open and every lifecycle version stays unchanged. Another current owner can see workspace invitations regardless of issuer. An empty workspace gets 200 with an empty array. Anonymous, member, stale membership version and stale security stamp sessions receive the expected denial. All 110 tests pass. We turned a simple list into an explicit privacy boundary. The endpoint accepts no trusted scope from the caller. Tenant owner performs the outer authorization, and the store rechecks the live user, selected tenant, membership version, role and identity stamp inside a consistent read. The database filters tenant and closed state before materialization. Only the management identifier, canonical recipient and expiry enter the response model. Expired snapshots are excluded without changing history, and provider-aware ordering happens only after the safe projection. No store keeps recipient data out of reusable caches. Tests prove both what appears and what cannot appear, including another workspace's recipients and internal capability material. Next, we can build an owner-facing Blazor invitation panel that refreshes this list and cancels an invitation by its non-secret management identifier.